Hello, my name is Allison Moore, and I'm a project manager with the Global Navigation Aeronautical team in Redlands, California. Joining me today is Brandy Robledo, a technical specialist who is also a member of the Global Navigation Aeronautical team. We want to welcome you all to today's training seminar, Introduction to PLTS Aeronautical Solution for ArcGIS 9.2. For those of you who are unfamiliar with the acronym, PLTS stands for Production Line Toolset. In this training seminar, we will introduce you to the PLTS Aeronautical Solution extension and demonstrate how these tools can help manage aeronautical data and drive the generation of numerous aeronautical products. The topics presented in this training seminar will be: what is the PLTS Aeronautical Solution? Then we will cover management of a central geodatabase, creation of aeronautical products, and end with demonstrating how aeronautical information systems can be extended. Each of these topics will be followed by a software demonstration and review. Also, we will go over a list of frequently asked questions regarding the aeronautical solution at the end of the seminar. Let's begin by learning a bit more about what the PLTS Aeronautical Solution is and how it fits into the PLTS framework. PLTS, again, stands for Production Line Toolset. It is an extension to the ArcGIS desktop product. The purpose of PLTS is to help with the overall production process. With PLTS, you have tools that help to manage the production workflow. There are also tools available to help streamline data production and maintenance. These tools are designed to provide an efficient editing and attribution environment. Another component of PLTS has been specifically created for performing data review. This includes automated review tools, visual review tools, and documentation of errors. PLTS also contains tools designed to enhance the cartographic map or chart production process, including tools that help you build and manage a map series or a map book. As we start to explore the PLTS extension, you will see that there are two tiers to the product. The first tier is known as PLTS Foundation. This is the base tier, providing you with all of the workflow management, data production, data review, and cartographic tools. The components of PLTS Foundation are job tracking for ArcGIS, which is the workflow management component, foundation tools, which are the component of PLTS Foundation that contain the data production and maintenance tools to streamline the editing and attribution environment. The GIS Data Reviewer contains tools for performing data QC. Checking the data quality is an important part of the production process, and the Data Reviewer provides a complete review environment. And finally, the Map Production System Atlas, which is your cartographic aid. MPS Atlas contains the tools and functionality for producing a series of high-quality cartographic products. The second tier of the PLTS product is termed the Solution tier. A solution provides users with database and cartographic templates that are geared towards meeting the standards for their chosen industry. In this seminar, we are going to focus on the Solution tier, specifically the Aeronautical Solution. The Aeronautical Solution comes with additional tools to help meet industry standards for aeronautical data creation and maintenance and aeronautical cartographic production. Each solution is sold separately and includes all of the components from the Foundation tier, which I have just discussed. The PLTS Aeronautical Solution provides efficient management of aeronautical data and products. The main components to the PLTS Aeronautical Solution are data management, which supports the constant need of data to be loaded, viewed, edited, and validated. Product management, which enables data to be used to generate a number of different aeronautical products with various symbol sets and productivity tools. And workflow management, where different tasks throughout the life cycle of the aeronautical data can be created, assigned, and tracked. These core components of the PLTS Aeronautical solution can be wrapped up to serve a larger enterprise-based organization. In today's seminar, we will be focusing on the data and product management components. More specifically, the aeronautical solution provides the ability to manage aeronautical data in a central location, with additional support for the Aeronautical Information Exchange Model, or AIXM, as well as the ability to manually enter data through a parameter-based feature creation tool called Feature Builder. There are a number of products supported with the PLTS Aeronautical solution. Standards that are supported include NGA, FAA, and ICAO charts. These products can support a wider audience of customers and can be tailored to meet specific needs. Now I'm going to turn over to Brandy, where she is going to highlight some of the components I've just discussed.
As part of the introduction to the PLTS Aeronautical solution, this software demonstration will allow you to see a few examples of finished aeronautical products. We will briefly cover the toolbars and symbology specific to the PLTS Aeronautical solution. Finally, we will see the nuts and bolts of the geodatabase that are used to create aeronautical products in ArcCatalog. We are currently looking at a PDF of an Instrument Flight Rules aeronautical chart. One thing about this chart to note is the ICAO look and feel. Next, let's take a look at one of the terminal procedures charts. We are currently viewing the ICAO Visual Approach chart. On a side note, the PLTS Aeronautical solution allows for the creation of those terminal procedure charts that are not to scale. We will discuss a few of the tools provided with the PLTS Aeronautical solution used to create these charts in later software demonstrations. Now let's take a look at one of the chart templates in ArcMap. The data used to create this chart is stored in a geodatabase, as is all of the aeronautical data when using the PLTS Aeronautical solution. One of the first things I would like to quickly point out here is the set of 5 PLTS Aeronautical toolbars. The PLTS Aeronautical Annotation Toolbar contains tools that, as the name implies, apply to annotation on the aeronautical charts. On this toolbar, you will find the Create Feature-Linked Annotation tool, Rotate Annotation tool, and the Select Annotation tool, among others. The PLTS Aeronautical Data Management toolbar contains tools that you can use to manage the features in the AIS. The PLTS Aeronautical Editing toolbar has tools that we use for editing the aeronautical information system data. The PLTS Aeronautical Layout toolbar contains tools that allows us to create and update the surround elements on an aeronautical chart, such as the scale bars and chart leads. And last but not least, we have the PLTS Terminal Procedures toolbar. This toolbar contains the tools specific to the creation of terminal procedure charts, like the Profile tool and the Graphic Table Element tool. I would also like to bring your attention to the symbology that we are using in this chart. The symbol set is the ICAO symbology, just one of the many symbol sets included with the PLTS Aeronautical solution. Finally, let's take a closer look at the geodatabase that drives the PLTS Aeronautical solution in ArcCatalog. One of the first things you will notice is that there are several feature classes. Feature classes are the containers in which features are stored in a geodatabase. Inside each of these feature classes are populated fields. Each of these fields contains the information used to create and maintain aeronautical charts. Through a series of relationships within the geodatabase among feature classes, it is possible to relate one feature to another, one feature to many features, or many features to many other features. We can look at the Preview tab to see what my aeronautical data looks like in a graphical depiction. We can also look to see the exact same data in a tabular form. So, in this demonstration, we have seen finished aeronautical products and viewed the aeronautical data in ArcMap, emphasizing that the PLTS Aeronautical solution provides specialized tools to create aeronautical charts. We also viewed the geodatabase in graphical and tabular form in ArcCatalog. At this point, I'll turn it back over to Allison so she can continue with the presentation portion of today's seminar.
When it comes right down to it, the PLTS Aeronautical solution can be used to help manage aeronautical geodatabases, maintain quality data, produce a number of different cartographic aeronautical products, as well as manage workflow. Let's continue and discuss the first building block of the PLTS Aeronautical solution, data management. The Aeronautical Information System, or AIS, is composed of a central repository that is AIXM-based for all of the aeronautical data. This is also where the various data integrity rules and workflows can be stored. The aeronautical solution provides many tools to create, load, and maintain the AIS. Key benefits of the AIS are that the data can be stored and viewed in a geospatial environment, allowing users to better see how features relate to one another, therefore producing higher quality data. Also, due to the data-centric environment, edits performed to the data need only be done once in the geodatabase, and those changes are automatically reflected on a related chart product. The AIXM-based geodatabase model included in the 9.2 solution allows agencies to exchange data internally or externally via AIXM transactions. Being able to exchange aeronautical data is a very real concern and a top priority for aviation organizations around the world. Using the AIS within the PLTS Aeronautical solution, users can tap into the ability to load multiple sources and formats of data to help build and maintain their geodatabase. Loading applications or workbenches developed for the feature manipulation engine will enable users to load in anything from legacy CAD data to AIXM transactions from a neighboring organization. Using ArcGIS and PLTS, users can fuse multiple data sources in the geospatial environment. This can better support data validation. An example seen here is placing imagery underneath the vector data to compare the accuracy. 3D visualization within the geodatabase is also a useful tool in helping to validate the spatial relationships and the vertical attribution of features, as seen here in this example. Many users may also have the need to manually input or maintain data in the geodatabase. Using inherent GIS functionality to edit this data in a graphical environment, such as seen here, users can be assured higher quality data as changes are made directly into the geodatabase. While the graphical environment is useful to understand the spatial relationships between data, the ArcGIS interface is also helpful in inputting attribute-based information as well. Feature Builder is an example of a tool that can be used to help manually input these complex features via parameter-based entries and shortcut operations. ESRI technology manages quality in many ways. The key is that data are inherently spatial, and thus spatial relationships in a geodatabase can be better managed than in a tabular database. Users have the ability to manage the quality and validity of data as it is being entered into the database using domains and ranges, topology rules, and condition tables. An example of a topology rule might be that an airway entered into the geodatabase must have endpoints, and an example of a condition table could be that airport runways must have a runway length that is between a certain range of valid values. The parameter-based input screens available with Feature Builder ensure that all pertinent data is entered to create a specific type of geometry. Advanced visual and automated batch QC tools within PLTS GIS Data Reviewer support the need for QC further into the production lifecycle. Brandy is now going to take over to show some of these data management components within ArcMap.
In this demonstration, we will talk about quality in the geodatabase using condition tables. You will also see an example of how feature-linked annotation can be used to shorten manual editing time. Finally, we will create and attribute a new feature using Feature Builder. The data that we are currently looking at is the same data we viewed on the aeronautical chart from the previous demonstration, and the same data we saw in table format in ArcCatalog. As you can see, I am displaying aeronautical data such as ATS routes as well as nav aids, but I'm also displaying some topographic data to add an element of elevation to my aeronautical data. This is an example of our ability to fuse different data sources into the same display and chart. Let's go into a more typical editing environment with fewer features displayed. In the first demonstration, I showed you a few finished products. Now I will show you a possible scenario should data change or perhaps a new feature is added. You will see that the runway information for the Borrego Valley Airport is now visible. The runway currently has a runway length of 5,011 feet. Let's say that I'm an analyst that has received a change to this runway. The runway length is no longer 5,011, but is 6,000 feet. So I need to make this change to the data. So remember in the first software demonstration, we were talking about the relationships in the geodatabase. If you look with me in the PLTS Selection tab, you will see that I have the Borrego Valley Airport selected. I can burrow down through the tree structure to see all of the other features related to this particular airport. I am looking for the ADHP Surface Area Feature class. This is where our related runways are stored. Now I need to change the runway length. So I know that the length is stored in the length_val field. So I can change this to 6,000 feet and click Apply. You'll notice that a message box has appeared letting me know that the value I entered, 600, is not a valid value for this particular field. The rule in the condition statement states that the runway length values must be greater than 1,000 feet. By inadvertently typing 600 instead of 6,000 feet, I violated this rule. This quality check is referred to as a CNT or condition table that Allison talked about earlier. So let's dismiss this message and go back into the field and input the proper value of 6,000 feet. You will notice that I no longer receive the warning message. One of the other things I would like to point out here is that the runway length annotation that we are seeing automatically updates from 5,011 to 6,000 feet without me having to manually change it. This is the concept of feature-linked annotation. As a feature is updated, the associated annotation will automatically update to reflect those changes. Allison has also mentioned the robust data creation tool, Feature Builder. So now that we have correctly updated the runway information for Borrego Valley, one of the other changes I received is for a keyhole airspace to be created over Borrego Valley Airport. I'm going to use the Feature Builder tool to create this new airspace. The first thing I want to do is launch the Feature Builder application. Feature Builder has its own toolbar, the PLTS Feature Builder toolbar. Feature Builder is a dockable user interface, meaning that I can choose where I want Feature Builder to reside. Feature Builder has many default functions for the creation of different features. For each function, the number and type of user inputs required for that function changes. If I choose to create an arc, then at the top of the user interface, it indicates that I need to choose 2-point features. We need to create a keyhole airspace. So you'll notice that I only need 1-point feature. You'll notice I only need to select one of these points. So I will select the Borrego Valley Airport, as this is the point that I want my airspace created around, using the pinprick tool on the PLTS Feature Builder toolbar. You'll notice that after I've selected the airport, the coordinates of the airport have been entered into the user interface for me. I then need to fill out the other user-defined parameters at the bottom of the user interface. As a note, I have already chosen the units of measurement I want to use to create this feature in a properties page that I populated in the setup of this MXD. So as we are already editing our geodatabase, I can select the correct feature class in the PLTS Target tab. This enables me to pre-populate the feature before I actually create it. So some of the fields we want to populate are the name. We'll call it Brandy CTA. Then we'll give it an upper altitude value of 6,000 feet. Then we need to decide what kind or type of airspace we want this to be. So as we've already noted, we want it to be a control area. And then the class of airspace will be Class E. So since now we can enter our parameters. So for the radius, I will choose 6 nautical miles. The azimuth, we'll choose 110 degrees. For the azimuth distance, we will enter 11 nautical miles. For the left buffer, 2 nautical miles, and the right buffer, also 2 nautical miles. So at this point, we can click the Execute button. Go ahead and make this a little bit smaller so we can see everything. And you'll notice that our new keyhole airspace has been generated inside our geodatabase. So now all I have to do is save my edits and stop editing. And I have finished adding a new feature to the Aeronautical Information System geodatabase. In this demonstration, we have seen an example of how quality can be built into the geodatabase with the use of condition tables that can limit what values are acceptable for a specific field. You have seen how changing an attribute on a feature that has feature-linked annotation associated with it will automatically update the annotation. We have also created a new airspace with Feature Builder and correctly attributed that feature in the geodatabase. I'll turn it back over to Allison to continue the presentation.
In review, the aeronautical solution contains a number of tools to help manage data. These include the ability to exchange data of multiple formats, utilize the graphical environment to manually enter data, and thorough quality assurance of the data throughout the workflow. Let's now switch our focus to the aeronautical charting component of the PLTS Aeronautical solution. There are a number of products that are supported out of the box with the PLTS Aeronautical solution. Tools to generate and maintain terminal procedures, instrument charts, as well as visual charts are included. Sample charts for these products are provided with the PLTS Aeronautical solution, and those samples are fashioned to meet the ICAO Annex 4 specification, as well as U.S. military and civilian regulations. The sample charts are configurable to meet user requirements, as most chart publishers have their own interpretation of Annex 4. Users can use the samples provided in the solution as a starting point, but have the ability to modify symbology, colors, and text, as well as fuse additional data sources to create new customized products. The PLTS Aeronautical solution provides advanced database-driven cartographic tools. The tools are developed to assist users in more efficiently creating and maintaining these complex products through a number of batch processes and suggested workflows. The PLTS Aeronautical solution provides the ability for users to generate complex annotation elements in bulk and provides streamlined annotation placement tools. Some of the more complex custom callouts can be seen here in this example of the Navaid callout boxes. Aeronautical fonts, symbols, and styles are provided with the release solution, and the sample charts show examples of how the layout can be portrayed. A great time-saving tool is included to help generate chart leads. A new tool called the Graphic Table Element helps users generate database-driven tables in a flexible and configurable environment. The interface can be likened to Microsoft Excel and can generate elements such as minima tables and pilot briefing sections on an instrument approach chart. This graphic is an example of an ICAO en route aeronautical chart. It is very similar to the chart Brandy first showed in her demonstration. In the next few slides, I would like to point out just a few of the advanced cartographic productivity tools included with the PLTS Aeronautical solution. Brandy will be going into some more detail in her next demonstration on some of these features. The buffered polygon renderer allows the user to change the appearance of a polygon feature on screen without changing its geometry in the geodatabase. This tool can buffer inside or outside a polygon with user-defined parameters using any type of fill symbol. Tools such as the line bypass have built-in logic that will determine if a line feature needs to have its geometry modified to bypass a point feature. The open architecture of these tools allows users to input parameters such as specific line feature classes to process and can be customized further for an organization's specific requirements. The profile tool is a tool developed in support of the terminal procedure charts. This database-driven tool will automate the generation of the not-to-scale components of the charts. Our ability to block out or mask features on a chart adds better visibility and allows users to customize feature priority. Masking polygons are created and stored in the geodatabase. A set of rules is then assigned to each type of mask. These masking settings can be created to show different masking rules for different products. In this example, you'll see that the bearing value 255, as well as other features, are blocking out or masking the underlying line feature. Cartographic representations offer an improved solution for manual cartographic tasks. The user can better manage the appearance of features on a feature class level, but also have the ability to manage the appearance of individual features. This is called an override. These settings are also stored in the geodatabase. The example shown here is that multiple representations can be stored for one feature class, the airway routes, for example. And in this example, the arrowheads can be offset from the endpoint of a route. A visual example of many of the concepts I have just discussed can be viewed here on the terminal procedure. The graphic table element has generated these various tables at the top of the procedure. We then used cartographic representations to symbolize all of the data in the plan view. Feature Builder has been used to generate some of the data, and the Profile tool has been used to generate this profile. We also have another example of the graphic table element tool being used to generate tables for the procedure. To touch upon the workflow management component of PLTS, let's talk quickly about the job tracking extension for ArcGIS and how it can provide a more advanced workflow management. This PLTS Foundation component works directly with ArcGIS Desktop and PLTS to help manage task completion. Using JTX, you can define the workflow for jobs that are being completed. The workflow outlines what needs to be done in the order that the steps need to be completed, as shown here in this graphic. JTX can also be used to assign jobs or tasks to different users in the organization, track the overall job progress, and can be used to record feature-level transaction history, capturing all changes made to a feature during an edit session. You can learn more about JTX by listening to the web-based training seminar titled Introduction to Job Tracking for ArcGIS. This free seminar is available from the ESRI training website. I will now pass it back to Brandy, where she will further explore in ArcMap some of the advanced cartographic tools I've just mentioned.
Allison has just talked about a few of the advanced tools available for productivity and symbology. In this demonstration, we will take a look at the graphic table element tool as well as the profile tool. We will also create an override to a cartographic representation to make a feature appear differently than the other features on the same chart. I now have an ICAO instrument approach chart template open. Let's zoom into the communications table to talk more about the graphic table element tool. This tool allows for the creation of tables on charts where the data is dynamically linked to the graphical table element displayed. As the data changes, for example, a frequency for a control tower, the graphic on the chart will automatically update. You will notice that there are 4 cells present, 2 containing text and 2 containing frequencies. I'm going to change the frequency of the Lindbergh Tower from 338.225 to 330. In order to do this, I will manually change the data in the services feature class. So you'll notice that I've brought up the attributes table, and let's scroll over to find that frequency. So we'll make the change. And if you'll watch this cell as I apply the edits, save the edits, and the tool automatically updates the information inside the table. In the creation of this table, I can decide which cells I want to be static, such as the text, and which ones I want to be dynamic, like the frequencies. I have control over what color and symbol the cell borders are, and whether they are filled or not. what size they are, for example. I can also determine the font and color of the text. Inside this user interface, I can also determine whether I want the cell size to grow and shrink according to what data is present. So I can go into the table design. Let's make this a little bit bigger so we can all see it. You'll notice that this is a replica or an example of what we have shown on the graphical display of the chart. So let's go into the properties of this cell. And I want to change the border. So let's change the border symbol to the highway ramp symbol. So we click OK, and we click along these borders, this edge. We click OK. You'll notice in the preview window that our changes have been updated. And as I click OK, you'll notice that our cell for the Limburg Tower has been updated to the highway symbol. So next, let's take a look at the profile tool. We'll need to zoom into the bottom of the chart. And as you may know, creating the profile view for a terminal procedure chart can be tedious, as well as time-consuming. With the PLTS Aeronautical solution, the software does the work for me. With a single button click, all of the data needed in order to generate the profile view is gathered, and a profile view is generated for the chart I am working on. We will need the PLTS Aeronautical Terminal Procedures toolbar for this exercise. Now remember, everything I need to create the profile view for this chart is already stored in the geodatabase. So all I need to do is simply click the Instrument Approach Profile View tool and select the appropriate procedure. Click OK. And the profile view element is created. So at this point, all I need to do is move it into place. So let's switch gears back to editing. I'm going to bring back up the ICAO sample chart we were looking at in the first demonstration to talk more about some of the robust cartographic utilities offered with the PLTS Aeronautical solution. We will begin with cartographic representations. But first, let's turn off all of these layers to make it a little bit easier for us to see everything. We just need navaids and ATS routes on at this point. Go ahead and start editing our geodatabase. Cartographic representations allow users to store symbology for features in the geodatabase. These rules are usually applied to all features. However, there is always at least one exception to the rule. By applying an override to a feature's cartographic representation, it is possible to change the symbology of one feature as opposed to changing the entire feature layer symbology. Let's take this compass rose, for example. Let's say that for some reason, this particular compass rose needs to be rotated differently than all of the other compass roses on this chart. We can go into the properties of the compass rose layer and view the attributes. You'll notice that our compass rose is actually made up of two different marker symbols. We have the navaid marker symbol, and then we have the rose symbol. So we want to be able to rotate the compass rose without rotating the navaid. So we can simply go in and change the rotation angle. And you will notice that our navaid has rotated, but our compass rose has rotated, but our navaid has stayed the same. So let's go look at another one of our compass roses just to be sure that the rest of them stayed the same. You will notice that this compass rose has not rotated because we only applied the override to one feature. Further information on cartographic representations can be found by viewing the free training seminar, Introduction to Cartographic Representations in ArcGIS 9.2. The link will be provided at the end of this seminar. So, do you remember the airspace that I created in the last demonstration? Let's go back and take a look at that area again. We'll turn back on all of our layers again. Now, I want to remind you that we are still looking at the very same data that we viewed in the previous demonstrations. A new keyhole airspace has appeared over the Borrego Valley Airport. This is the airspace I created with the Feature Builder tool in the second demonstration. You'll notice that the new airspace is symbolized like the other airspace around it. This is due to the PLTS Visual Specifications tool, or VST. This robust tool allows for the symbolization of features and the creation of annotation by pulling data from several different feature classes and relationships using a series of SQL statements. The information needed to correctly symbolize airspace and any other feature on a chart is stored across many feature classes. VST makes this possible. In this demonstration, we have seen just a few of the productivity and symbology tools that are included with the PLTS Aeronautical solution. The Graphic Table Element tool allows for the dynamic linking of table cells to the data stored in the geodatabase. The Profile tool greatly reduces the time needed to create the profile graphic displayed on certain terminal procedure charts. Cartographic representations allows you to change the appearance of a feature without changing the underlying geometry of that feature. And finally, the PLTS Visual Specifications tool allows you more flexibility in the symbolization of features as well as in the creation of labels and annotation through the use of SQL statements. This concludes the software demonstration portion of today's seminar. At this point, I will turn it back over to Allison for the remainder of today's presentation.
As Brandy has just demonstrated, the PLTS Aeronautical solution provides tools for creating database-driven aeronautical products, allows users to customize symbology to meet their specific requirements, and helps us solve many of the complex cartographic problems seen with legacy systems. The PLTS Aeronautical solution can also utilize the job tracking extension to help manage the production workflow. Our next and final topic for today's seminar will explore how users can extend the aeronautical information system. While the AIS geodatabase is the central hub that interacts with data content as well as drives product generation, it can also drive a variety of enterprise-based applications. Using a number of other ArcGIS extensions, the aeronautical data can be displayed in many different ways. One of these enterprise-based applications is called Product on Demand. The Product on Demand application can produce and deliver high-quality cartographic products via ArcGIS server. The essence of POD is that the server makes a new map or chart from the latest and greatest data available based on a unique user request. POD is ideal for situations where users want custom output, such as location, or when data are changing rapidly, such as aeronautical or nautical data. A user simply requests a chart at a specified location, has the ability to set some advanced options, such as output format type or layer visibility, and the application returns the product to the user. In this example of extending the AIS for analysis purposes, the FAA used GIS to quickly identify the highest point within air traffic zones by analyzing the minimum vector altitudes. Here, the FAA used 3D tools to evaluate navade coverage and terrain to determine gaps in navade coverage for general aviation pilots. Again, using 3D tools, line of sight analysis was merged here with 3D building and terrain data, airport layout data, aircraft approach and departure data, and shoulder-launched missile ranges to determine high threat zones around Reagan National Airport. With the help of the Tracking Analyst extension, both real-time and historical aircraft position data was used for noise analysis, airport capacity analysis, and scheduling. GIS can help make flight planning and route allocation decisions and provide general asset management reporting support. Various statistical reports can also be generated of those same analysis tasks. The FAA uses GIS to geolocate their inspection equipment and personnel in order to place the correct capability close to the greatest need and make decision on where to deploy their assets. GIS can provide tools and functionality to better manage airport facilities, as seen here in an example from McCarran International Airport in Las Vegas, Nevada. The ability to visualize the aeronautical data in ArcGlobe or ArcGIS Explorer opens many new opportunities to organizations, just as the ability to fuse live weather data over aeronautical data to help with flight planning is also a very useful capability that is inherent to ESRI products. In closing, we wanted to go over a few of the frequently asked questions as they relate to the PLTS Aeronautical solution. First, what versions of AIXM are supported at the 9.2 release? We are currently supporting AIXM 4.5, but ESRI is an active participant on the AIXM Change Control Board, so we will be upgrading to 5.0 as those drafts become finalized. Do I, as a user, have the ability to modify symbols to meet my specific requirements? Yes. As we mentioned in the seminar, the solution comes with symbols and styles that have been developed to meet the ICAO Annex 4 standards, but the ArcMap interface allows users to directly edit and manage the symbols and styles for their own needs. Can I hire ESRI for supporting the implementation of the PLTS Aeronautical solution? Yes, the Global Navigation team within Database Services is available to support you with custom training, configuration support, cartographic production support, and more. Your comments help us to improve our seminars. Please take a moment to complete our survey. Just click the evaluation link on the left-hand side of your browser to take the survey. For additional resources relating to many of today's topics, please click the What's Next link on the left-hand side of your browser as well. We hope you have enjoyed this seminar. On behalf of ESRI, we'd like to thank you for attending. Goodbye.